Hello everyone. Today I came up with another slightly odd idea, building a homemade welding device using a turnbuckle from the construction world. For those unfamiliar, a turnbuckle is a tool that adjusts tension in cables or wires, twists its body and the opposite threaded ends pull tighter or spread apart, generating impressive force with almost no effort. Honestly, I wish my lower back worked with the same efficiency. On job sites, turnbuckles keep scaffolding steady, tighten support lines, secure temporary steel frames, and fine-tune lifting cables so nothing wobbles when it shouldn't. Small tool, big responsibility. Alright, that should be enough of an introduction for today's star. And for what we're building, we won't need the hook ends. I'm saving those for a few fun projects coming soon. Now then, let's get to work. Next, I've got an empty motorcycle valve stem here. If you've followed me for a while, you already know it's no surprise that I use this little piece as the welding tip for my homemade welding setups. It may look like nothing special, but this hollow valve stem has just the right size, handles heat surprisingly well, and when repurposed properly, it performs so nicely that I sometimes forget its original job was to inflate tires, not to lay down welding beads. Attaching the valve stem to the rounded end of the turnbuckle isn't exactly straightforward. These two parts were never designed to cooperate, so getting them to stay together takes a bit of persuasion. That's why we'll need two metal hose clamps to lock the valve stem firmly onto the turnbuckle head. The clamps will hold everything tight, preventing slipping, twisting, or wobbling once we start welding. In other words, it's like hiring two security guards to make sure these two stubborn pieces finally agree to work together. Here I've got an additional piece of electrical wire, and its purpose is pretty straightforward. We'll connect one end of this wire directly to the welding tip we just assembled. The other end will be fitted with a crocodile clip, small but incredibly handy. This clip will attach to the positive terminal of the power supply, allowing the current to flow steadily into the welding tip. To keep the electrical wire from dangling or getting in the way, we'll use tape to secure a section of it to the handle. This simple trick keeps the wire aligned with the handle, preventing tangles or accidental knocks while welding. In other words, it's a way to teach the wire to stay in its place instead of wandering around. In my hand, I have a dead AA battery, and as in previous videos, I'm going to repurpose the inner core as a DIY welding tip. First-time viewers may find this hard to believe, but the core still conducts electricity and withstands heat well, even though the battery no longer produces current. Its role isn't to supply the main current, but to carry electricity from the power source to the welding tip and keep it stable. Moreover, the core's size fits perfectly into the welding tip. The material is durable and conductive, and its slim shape makes installation straightforward. Another interesting point is that this carbon or metal core can handle the localized heat at the welding point without deforming or burning, meaning it remains reliable even during continuous use for several seconds. Additionally, the solid structure of the core helps the welding tip stay firmly in place without wobbling, a common problem for newcomers attempting DIY welding setups. And of course, making full use of something that would otherwise be discarded is part of the DIY spirit I like to share. These small but crucial properties turn a seemingly dead battery into a surprisingly useful component for our DIY project, saving material and giving new life to something most people would throw away. So our welding tip is now ready. The next step is to attach it to the valve stem to complete the assembly. At this stage, make sure the tip and the stem fit securely without wobbling or misalignment, because the stability of the joint directly affects the performance and safety during welding. Think we're done? Not yet. Next, we'll prepare an electrical wire with crocodile clips at both ends. The purpose of this wire is to connect to the negative terminal of the power supply, completing the circuit for the welding head. When connected correctly, electricity will flow from the power source through the wire and the welding tip, generating the heat needed for welding and ensuring the device works safely and reliably. This step is crucial. It's what really brings our DIY welding head to life. To power our DIY welding setup, I'll use a small battery. It has suitable specifications, providing enough current and voltage for the welding tip to operate steadily and safely, while preventing overload or voltage drops during use. We've succeeded. When the two power terminals meet, the welding tip heats up instantly. Next, I'll run a few small tests so you can see its real performance. Stick around to catch the full results. After all those small tests, I can confidently say it's a success. The DIY welding setup works steadily, the tip heats up quickly, and it's easy to control. This project shows that with a few simple materials and a bit of creativity, items that might be discarded can be resurrected into useful tools. The best part of making it yourself is not only understanding how it works, but also experiencing the satisfaction of seeing it run smoothly. I hope this video inspires you to try other DIY projects and make the most of the materials around you. Thanks for watching, and if you try making this mini welder, be sure to share your experiences and tips.